All right. 8.1, the addition or elimination method, solving systems of equations. This is example number 2. Our system of equations this time is 3x minus 7y equals 13 and 6x plus 5y equals 7. Ignore temporarily the red box around 3x and 6x. Of course, it doesn't come written that way. But that is me trying to draw your attention there, because what we're trying to do is sync up either the x values or the y values. We want positive and negative versions of the same terms. So, in theory, you could do it with either one, 3x and 6x. If you do, 2 times 3, you're going to get also to 6. And then if you do minus 2, that's probably going to be the easiest, which is why I have it circled. Let's sync the x's at positive and negative 6x. You're going to end up multiplying the top of the top equation by minus 2. In theory, right, if for whatever reason you just love 5s and 7s more than you like 3s and 6s, you could also work with that. I mean, they have a positive and a negative built into it. So you could do almost a cross multiply type move where you'd say 5 and 7, they would kind of meet up if we're trying to multiply. They're not going to meet up until we hit 35. So you would need to do the top equation times 5 and the bottom equation times 7. That would get you sort of a negative 35y and a positive 35y. That works. I mean, you can do that. The only thing there is, of course, obviously your numbers get a little bit bigger, and so maybe it's easier to make a mistake if the numbers get a little bit bigger. I'm going to stick with positive and negative 6x. So let's just multiply the top equation by negative 2. So I'm multiplying not just the 3x by negative 2. I'm multiplying the entire equation. So that's going to be sort of negative 2 times 3x is negative 6x. This is going to be negative 2 times negative 7y would be positive 14y, right? And negative 2 times 13 is negative 26. So in red here, in these brackets, which of course we're going to sort of deal with in a second, so negative 6x plus 14y equals negative 26, right? That's the new version of the equation. That's the top equation. So I'm just going to stack it over the bottom. 6x plus 5y is 7. And then I'm going to add those two equations together. So I have the columns there, right, that I'm sort of bracketing. Negative 6x, positive 6x. The whole strategy here is, right, get those in sync and then add them together so they cancel out. So that gets us to 0. The x's are gone. 14y plus 5y is 19y. 19, sort of like the 17 we had in one of the other equations, not necessarily the first number you want to see there. However, lo and behold, negative 26 plus 7 is going to get us negative 19. So the version here, right, the equation we're sort of ending up with, the simplified version, is 19y equals negative 19. If we just do a quick division by 19, you're going to see that the y value here is going to be negative 1, and we can sub that back into either of the first two equations, right? Let me just run that down again. 19y equals negative 19, so that's in purple, right? Divide by 19 on both sides to get the y value by itself. That gets us to y is negative 1. So we're halfway there as far as getting an answer. We're more than halfway done with the problem, because a lot of the work goes into just getting that initial value. Once you have it, you're going to sub it into either one. In this case, I've picked the secondary equation. It doesn't really matter. We can put it into whichever one we want to. So if y value is negative 1, we're going 6x plus 5y is 7. So if y is negative 1, 6x plus 5 times negative 1 is 7. That, of course, just means 6x minus 5 is 7. If I do a quick add 5 to both sides, plus 5 and plus 5, that's going to mean 6x is 12 in green. Divide by 6, divide by 6. My x value here should be positive 2. So my final answer, right, the final solution here is going to be the ordered pair xy is going to be equal to 2 comma negative 1, right? So the x value is 2 and the y value is negative 1. As a challenge problem, or if you just want to try this another way, maybe try it where you cancel out the y values instead. Do, the top times 5 and the bottom times 7 and go from there. The numbers will get a little bit bigger. But don't be intimidated by that. You know, in theory, it still works and should sort of go the same way, and you should end up with the same final pair. So that's an option for just a little bit of extra math fun.